welcome to our channel. My name is Dmitry and I'm a part of the ExactPro research team. At ExactPro, we build software to test software. Do check out our website, exactpro.com, if you want to learn more about us. You can also subscribe to this channel and hit the bell button to see the new videos. And trust me, we do have a lot of those coming up. Today, we're going to go over chapter number 3 of the IS2QB Foundation level syllabus titled Static Testing. If you missed the previous videos, you can find the links in the description below. Let's get to it. Testing objectives include finding defects and assessing quality. Static testing and dynamic testing are the two approaches that can be used to achieve that. With dynamic testing methods, software is executed using input values. The output is then compared to what is expected, and the results get analyzed. During static testing, the software is not executed, but examined manually or with tools. This process is all about reviewing the software code and requirements. Static testing usually begins early in the lifecycle, providing timely feedback on quality issues. Detecting defects from the very start keeps the rework costs relatively low. And since the correction effort is reduced, the development productivity figures are likely to increase. The evaluation by a team has the additional advantage because there is an exchange of information between the participants. And that is quite essential to the process. Let's say some of the key players get sick or leave the company during the final stage of the development. Their colleagues familiar with their work can still deliver the project on time. Static reviews range from very informal to formal. An informal review process is easy. You just come to your colleague and say, "Hey, I've written some code. Can you look at it, please?" You probably create a corresponding task in Jira, Redmine, or whatever the issue tracker your company uses. A formal review is much more complicated. For instance, we need to review a very important document or a piece of code. In this case, there are certain phases we need to go through. 1. Planning. It includes defining the review metrics, selecting the personnel, allocating roles, deciding the entry and exit criteria, and choosing which parts of the document to review. 2. Kickoff is the phase where we distribute documents and explain the objectives to the participants. 3. Preparation. Here we get ready for the review meeting by going over the documents, noting potential defects and questions. 4. Review meeting is a phase where we identify and log the potential defects and their severity. If the number of critical defects exceeds the exit criteria, the document must be reviewed again after rework. 5. Rework is spent fixing the defects found. And 6. Follow-up is needed to check if the discovered defects have been addressed. And that's not all. The formal review is usually done by a group of people with defined responsibilities. We will need the moderator to lead the review process, to determine the type of review and the composition of the team, and also to perform an entry check and the follow-up on the rework. The author to learn as much as possible in order to improve the quality of the document. The scribe to record each defect mentioned as well as the improvement suggestions. The reviewers to check the material for bugs, and the manager to allocate time in the project schedule and to decide whether the review process objectives have been met. And I understand it sounds a bit too much, so let's take a step back and start with the most casual type and then work our way up the formality of the review chain. It's a flexible process, and the team chooses how strict the review for this code should be. We have informal reviews, also known as buddy checks. They're basically inexpensive ways to get some benefit. These types of reviews may be performed by a colleague, which means that the usefulness will depend on the skills of your peers. On the bright side, all documentation is optional, so you could save time, which makes it a perfect companion for agile development. Walkthrough. Here we up the formality a notch. First of all, it comes in the form of a meeting. It's led by the author, and the scribe is mandatory. And even though the individual preparation and checklists are optional, the meeting still produces defect logs and reports. Other than finding bugs, this type of review is about exchanging ideas about techniques, achieving consensus, and participant training. Technical review. And again, the protocol becomes stricter. First of all, the reviewers, who should be experts in this or neighboring disciplines, must go through individual preparation. The meeting itself is optional, but if it does happen, it should be led by a trained facilitator with a scribe present. Checklists are optional, but the defect logs and review reports should be produced. Finding defects is still the key, but there are some additional possible benefits as well, like building confidence in the work product, motivating authors to improve, and considering alternative implementations. Inspection. Inspection is the most formal review type. Everything we have listed before applies here with the addition of entry and exit criteria, mandatory meetings, and checklists. As a result, metrics are collected and used to improve the entire software development process. Needless to say, all 4 types serve their primary objective. The bugs get raised and then fixed. This sort of developers' cooperation promotes the right approach to code ownership and accountability. It also helps to bring newcomers into a fold through onboarding and education. There's a number of review techniques that can be applied here. Ad hoc. Here, the reviewers are provided with little or no guidance on how this task should be performed. They often read the work product, logging issues as they encounter them. This technique is highly dependent on reviewer skills. Checklist-based. A review checklist consists of a question set based on potential defects, which may be derived from experience. Checklists should be specific and should be regularly updated. Here, the main advantage is the systematic coverage of typical defect types. Scenarios and dry runs. This technique provides better guidelines on how to identify specific defect types because it is based on expected usage. Perspective-based and role-based. Here, the reviewers take on different stakeholder viewpoints and roles. A crucial success factor in this technique is including and weighing the opinions based on severity and probability of risks. Static analysis tools are typically used by developers before and sometimes during component and integration testing. These tools demonstrate structural attributes, depictions of control flows, data relationships, and the number of distinct paths from one line of code to another. Modern integrated development environments can be considered a static analysis tool, since they build a simple table, check for coding standards compliance, and identify issues. For example, unreachable code detection, wrong usage of standard APIs, or conditions that are always true or false. The Pareto principle states that 20% of the code is likely to cause 80% of the problems, and the complexity analysis helps us to find that elusive 20%. The cyclomatic complexity metric is based on the number of decisions in a program. It is vital because it points to the amount of testing necessary to fix defects. The areas of code identified as more complex are candidates for the reviews and additional dynamic tests. Simply put, complexity metrics identify high-risk areas. Checking for adherence to coding standards is paramount. When we evaluate compliance, we need to define or adapt a standard or a set of rules. The tools called linters help a lot. They check your code compliance automatically. Why is automation important here? There are 3 main reasons for this. 1. The number of rules in coding standards is usually so large that nobody can remember them all. 2. It is very hard for a human to check some context-sensitive rules that demand simultaneous reviews of several files. And 3. If people spend too much time checking coding standards in reviews, it distracts them from looking for defects. This concludes our today's video. If you liked it, give us a thumbs up. In the next one, we'll concentrate on Chapter 4 called Test Techniques. Meanwhile, we do have a lot more interesting content on our channel, so feel free to subscribe and hit the bell button. That's all for now. Goodbye.